everyone, welcome back. Last video we worked on definite integral and you learned the basics on how to solve for the area under the curve. This time we're going to go a step further and find the area between the curve and the y-axis. So before we wanted to find, for example, if we have sine, for example, if we want to find this area, it's from the interval a to b, and the interval is on the x-axis. Now, we want to see the area where the interval is in the y-axis. So as you can see, these are the notes. So what you can notice is on the left-hand side, we have a function, this curve here, which is on the right-hand side. And our area will be calculated by the integration of f inverse of y from lower bound c to d. So this is just something that it'll be good to memorize because it's very helpful when you want to find the area between the curve and y-axis. On the other hand, on the right-hand side, we see that the curve here is on the left side. And if we want to find the area between c to d, then we just simply need to put the negative sign in front. So now let's apply that and find the shaded area of these functions between the interval, which is on the y-axis. So the first step that we want to do is find what is the inverse. So we have the function y equals to 3x plus 5. What we want to do is we want to isolate x. So in order to do that, we want to move the 5 to the other side. We'll do this algebraically, and we end up with x equals to y minus 5 divided by 3. So now we want to use the integration here. Now which one do we use? Let's see. So we have the area from 2 to 4 to negative 4 or negative 4 to 2. And we see that the area is to the left. So we will have to put the negative sign in front. So the area is going to be negative integral. We have lower bound is negative 4 and upper bound 2. And as the formula stated, f inverse of y, we simply need to put this in. So basically what we would do is we put x in. But we want to find in terms of dy. So that's what we did here. We found out what x is. And x was y minus 5 divided by 3 dy. So now we want to integrate it. So what is the integration of y minus 5 divided by 3? So the first thing that you want to do to make things easier is I can see that there's a fraction. This is a fraction, and I don't want that. So I could perhaps move 1 over 3 outside. So I could put 1 over 3 outside of the integration, and I'm left with only y minus 5. Then now I could do the integration on the inside. So y minus 5, the integration would be, it would be 1 over 2y squared minus 5y. And then now I can plug in 2 and negative 4 as y and find the final value. So I have negative 1 over 3 times, now I plug in the upper bound, right? So I plug 2 into y. So I get 1 over 2 times 2 squared minus 5 times 2 minus, let's just put it in brackets to make things easier. Now I'm plugging in negative 4 as y. So now that we have that, let's simplify it. 1 over 2 times 2 squared is just 2 minus 10 minus, and 1 over 2 times negative 4 squared is 8 plus 20. So now that we have that, let's just, for the lack of space, let's move some things away. Yep, all right. Here it is, so this is there. Okay, so now our simplified form should be negative 1 over 3 times. If you add all those values inside, we get negative 36. And our final answer should be 12 units squared. because it's the area. Great, now let's move on to another question. So now we have the function ln of x, and here which method should we use? Well, we can see that the area is from -1 to 2, and this area here is to the right hand side. So that means we want to use this integration where it is positive. So the first thing that I want to do is we want to find what f inverse of y is. So I have y equals to ln of x. I want to isolate x. Remember, ln is the same as log ex. So if I want to isolate x, I have e to the power of y equals to x. So now that we have x, we want to plug in x in. So first of all, let's write down our integral. So it is from the lower bound -1 to 2, and x is e to the power y. And we just need to integrate it. So if we integrate anything e to the power of x or e to the power of y, when we integrate that, that's the same as e to the y by itself, because when we differentiate, it's also the same. So when we integrate ey, it's just ey. And so now we want to plug in the values 2 and -1. So we have e to the power of 2 minus e to the power of -1, which is the same as e to the power of 2 minus 1 over e. And if we want to make a common denominator, then it will be e cubed minus 1. So we can just leave our answer as that, and there you have it. That is how you find the shaded area between the curve and the y-axis. Thank you for watching.